Hello everyone, my name is Julia Sheehan. I'm a third year financial maths and actuarial science student here in UCC, and I will be moderating the panel for this evening. I'm chairperson of the Women in STEM Society, so something I like to say and know a thing or two about. So I won't waffle on for too long because I'm aware it's already quite late in the evening. So I might just go ahead by asking our lovely panelists to introduce themselves. So we might start with Dr. Kelly Dean.
Yeah, sure. Hi, everyone, and thanks for joining tonight. So, I'm a lecturer and a principal investigator in the School of Biochemistry and Cell Biology. So, essentially, I teach biochemistry to first year students all the way to master's students, and I direct two master's programs, one in molecular cell biology with bioinnovation, and an MRes program in biochemistry and cell biology. And I have a lab currently of 5, 2 PhD students, 2 master's students, and we're working on RNA and how these RNAs affect cancer. So it's a cancer biology lab mostly. Yeah, I'm excited to be on the panel and to meet a lot of you tonight. Thanks.
Brilliant. And next we have Professor Denise OSullivan.
Hello, folks. Thanks for coming. I'm a professor in the physics department here at University College Cork, and I teach a range of physics and astrophysics modules in the department. You might hear from my accent that I didn't grow up here, although there are bits of Cork creeping in all the time. I grew up in the USA, and I did my PhD research at Brandeis University near Boston. And that research actually involved the analysis and interpretation of an entirely new type of measurement. The very first high resolution measurements of magnetic fields from energetic outflows from the centers of active galaxies. They're called jets, using a technique called very long baseline interferometry. And this is a cool technique in which a whole array of radio telescopes spread over the entire Earth can be used together to get very high resolution images. After I got my PhD degree, I did the usual sort of globetrotting that one does in research. I had postdoctoral research positions at the Jet Propulsion Laboratory in California and University of Calgary in Canada. And then I went to Moscow, Russia to work at the Lebedev Physical Institute for about 5 years. And that was done in the framework of a project to actually do this VLBI technique, but using one telescope in space in orbit around the Earth. I eventually landed as a college lecturer in astrophysics here at UCC in early 2002, and I've been here since then. And my research has continued to use this technique to obtain very high resolution images of these jet outflows from centers of galaxies and at radio wavelengths. But I now have carried out many multi-wavelength and computational analyses to various samples of these objects. And one of the main topics of my current research is investigating observational clues that these jet outflows actually have spiral magnetic fields, a bit like a slinky, that move out with them as they move outward from the center of the active galaxies. And my group at UCC is the only one in the world that's focusing on this interesting new topic.
That was very interesting. Thank you, especially as a math student. I like hearing about the physics side of things. So next we might move on to Dr. Michelle Conroy.
Hi, so I kind of do the opposite of actually what Denise does. So I look at magnetic fields, but I look at the magnetic fields and the electric fields of atoms. And I look at smart materials, or I guess you could call them smart materials. There's different kind of words that people use because they're new materials and dynamic materials. Why that's so exciting, I think, is that for my applications, instead of, let's say you have electronic devices that are made of fixed components of hardware, that you think of it more like an etch-a-sketch. So you buy your electronic product, and then you can actually draw the circuitry around. But what's really, really important is we can't even move to the point of making these devices unless we understand the fundamental physics, the fundamental chemistry, and the material science, and the engineering. So they're all kind of coming together. And why I say I do the kind of like the opposite, I use these massive microscopes that look like telescopes, because they're about 2 stories high, and then I use those to probe the different positions of the atoms and their magnetic field, their band gap, and everything like that. So but at the moment, I'm at the University of Limerick, And in January, I got lucky that the Royal Society gave me funding to start my own research group. So I'm moving to Imperial College London in January, hopefully, when we can travel.
Fingers crossed.
Oh, and I should say I started in UCC. I forgot that. I started in UCC, so I did my degree in chemistry, and I've kind of done the globe trotting as well, and also different disciplines. So chemistry, then electronic engineering, then I work with nuclear and a geologist, and now I'm in the physics department, and now I'm moving to the material science department. So you can hop around and just keep following your interests, which is great.
Yeah, and that's actually something we'll be touching on in the first question. But before we do that, I'll ask Miss Ali Rose Sisk to introduce herself.
Hi everyone, thanks so much for having me today. Shellie, I'm based at UCL, so I hope we can link up for coffee real soon. I suppose a bit about my background. I am a nurse. I've been working in healthcare for the past 10 years. My background is neurosurgery and acute medicine, and I work in a tertiary hospital. So academically, I'm in the second year of my PhD. I'm a Marie Curie scholarship receiver, and my PhD is based at UCL, which is fantastic. Of course, home in Ireland right now, but yeah, heading back to London next year. And my PhD research really coincides with my clinical work in that I'm exploring the unmet palliative care needs of people with young onset dementia. So it's called frontotemporal lobar degeneration, FTLD. So there are many types of dementia, over 400, and 5% of those dementias are young onset. So adults as late 20s to 65, a really, really young group. So we're trying to prove these people have symptoms as do other chronic illnesses such as cancer, diabetes, and by proving that they have these symptoms such as pain, shortness of breath, we can slot them into existing care services and give them a better quality of life, and that's what it's all about. I suppose in terms of business, I am founder and CEO of a company called SafeCare, and what we do is we digitalize paper documents for the private care home industry, and that reduces the time us nurses spend on paperwork, thus giving more time back to the patient, increasing care quality. We actually reduce nursing home costs. So I wear many hats, and I've done my undergraduate work and my MSc work in UCC, and I've also done some teaching there at the college and absolutely fell in love with it and everything to do with it. So really glad to be here.
Thank you. And I think that's also something we try to push at YSTEM, is that the beauty of STEM is that you can be involved in loads of different fields. You're never going to be narrowed to one specific thing or one specific idea. So we're going to jump straight in. But just before we do, one of our panelists, we're supposed to have 5, is having some technical difficulties, so we'll see if she manages to join us, but it will be Professor Sarah Culloty, who is head of the School of Science, Engineering and Food Science here in UCC. So hopefully she joins us soon, but we'll see. We'll just plow ahead for now. And I would also ask that if you're not speaking this evening, you turn your camera off, just to make it easier for people to recognize who's on the panel and who isn't. So yeah, without further ado, we're going to delve into the questions. So the first question is, what are the most interesting projects you have been involved in that highlight why studying STEM is a great option for students to choose? So we might start with Denise for that.
Okay, thank you. Well, it's in a way, I feel like the path that my career has wound up taking is an answer to this question. When I first began studying these outflows from the centers of galaxies, everyone was thinking in terms of kind of local things like shock waves in the jets, or friction forces with the surrounding medium through which they were traveling as origins for the jet magnetic fields that we were observing. And there was a whole sort of bunch of models and so forth that were developed. And I was happily caught up in that for a while. And then we got some images that seemed to show something different. And I ended up being the first to find evidence that in fact, these jet outflows might carry spiral magnetic fields that are formed when the jets are formed. So in some sense, like intrinsic magnetic fields that just are born with the jets. And this was kind of expected from the point of view of theory, which is interesting, but not expected from the point of view of observations. And so that was really exciting. And I ended up being a bit of a lone voice for a while, but momentum was gained. And it's now started to open up whole new areas of study and make new connections between observations and theory. And so I'd say that the possibility of stumbling on and contributing to a whole new direction of research is very exciting. And so that would be my answer to this question.
Thank you. I love hearing about projects where people were trailblazers. I think it really does highlight the beauty of research in general, and it makes research so appealing to people, I think. So Sarah has actually joined us after a few stressful issues. So do you want to introduce yourself really quickly, Sarah, before we get on with the panel?
Sure, thanks so much, and apologies everyone. The joys of modern technology, laptops dying just at 5 to 6 and all sorts of things. So I'm on an iPad, so apologies. Yeah, my name is Sarah Culloty. I'm head of the College of Science, Engineering and Food Science at UCC. And I'm originally by training a zoologist and a marine biologist. And over the last few years, I've had various roles within the university. I've been the head of the School of Biological Earth and Environmental Sciences, and more recently the director of one of our large research institutes, the Environmental Research Institute. And now recently I've taken on the role of head of the college, and that represents over 5,000 students and staff within the university, all working in the STEM area and studying.
Brilliant. And just while we have you, what would you say are the most interesting projects you've been involved in that highlight why studying STEM is a great option for students?
Well, I suppose for me, a big part of it is actually all the unexpected opportunities. I mean, I think when we think about STEM, and even when I started my career, which was a long time ago, but it was even a very different environment. And the whole environment of STEM changes and evolves so rapidly. When we think of even what's happened this year with vaccine development and so many areas, the whole area is so transformative so quickly that I suppose what I've really enjoyed in my own career is working on aspects of research even now that I couldn't even have imagined, you know, when I started my career as an undergrad or when I was doing my PhD. And I mean, at the time, because I work on diseases of aquatic organisms, you know, we were very much taking a microscope-based approach and looking for parasites, and that's still a really important part of it, and trying to understand the diseases that we were looking at in different marine animals. But now it's very much a molecular-based approach. So, you know, all my students, it's molecular training. They actually need to work in the lab. So that has evolved really rapidly, and I suppose it's also allowed the students to have a really wide range of careers open to them even after the training then, because techniques like molecular biology are so ubiquitous in so many STEM careers.
Yeah, thank you. I think that's a really good point. Obviously, when we go to schools, one of the big things that we always push across is there's this whole notion that we're training people for jobs that don't exist yet. And STEM fully equips you for jobs that don't exist yet, because it's centered on problem solving rather than any specific field. And I think that's something we always try to push across. So Kelly, we might jump to you next. What are the most interesting projects you've been involved in?
Yeah, I would say, I mean, I always tell students I did biochemistry in 3rd year of college, and that was it. And that's all I do. So it's all molecules all the time. And I didn't do my I did do globe trotting. So I did my PhD at the University of North Carolina in Chapel Hill. And then I went to Heidelberg and University of Heidelberg at the Molecular Cell Biology Center. And that was a very exciting time because the lab was really at the cutting edge of trying to understand how molecules move in and out of the nucleus of cells. And our lab, group leader, Dirk Garlick, is one of the leaders in the field. And I specifically wanted to go there. And so that was really exciting. And then, you know, I love what I'm doing now because I've sort of picked up these skills along the way, and my research program it's still on RNA, which I did as a PhD student. It incorporates stuff that I did as a postdoc at Duke University. And then I have moved into cancer biology, and I'm really trying to, you know, solve what is a really complex disease and just look at one tiny aspect. And kind of, I think what's really changed for our field is that we can look at all the molecules in a cell at one time. And that technology didn't exist when I was a student, but now I'm finding that, you know, I'm having to learn along with my students how to solve these problems. And there are huge amounts of data, and how you can actually interrogate that data. So now I have like bioinformaticians in my group because I need them. I need them to help me because I was not trained that way, but I appreciate the data. I know what the question is. I know kind of what direction we're going in, but they have the skills to help me and help the group get there. So, I think a STEM career is, I've gone from the US to Germany, back to the US and to Ireland. I've worked on different projects. I've picked up skills along the way, and that has really shaped my teaching and also my research program. So, you really need a multidisciplinary team to solve big problems. And like COVID, like we're facing, like climate crisis, everything. So we need different skills for sure.
Yeah, no, and that's actually something that came up in the last of these panels we did as well. That the beauty of STEM is how multidisciplinary it actually is. So you can consider something like cancer maybe is probably more focused in a biochemistry field, but you need mathematicians as well, because you need to analyze the data and you need to draw conclusions from it. And that is really, I think, the biggest beauty of STEM. Also, it was nice to hear you've been to Heidelberg. I have family there, and it is one of the most beautiful places I think I've ever been in my entire life.
Heidelberg was amazing. I was really meant to be there for 3 months, and it turned out to be a year and a few months.
Beautiful. I probably wouldn't leave if they let me into that university. But moving on from that, Miss Ali Rose, what have you been involved in?
Yeah, goodness, like I've been involved with many projects along the road, but I think two that stand out to me most was definitely my MSc project, was building a dementia communication intervention based on the VERA framework. So what that really meant was we went into students after identifying that nursing students, were particularly afraid of interacting with people with dementia. They were afraid to go along with the altered reality. They were afraid of being accused of lying. Were they doing the right thing? Were they doing the wrong thing? So we identified the problem and we went in and we found the solution in that we developed a 1.5-hour workshop teaching students validation therapy. So actually you're validating the person's emotion as opposed to the content. So if you're validating that they're worried about missing the bus, you're not worried about the actual bus or if it's there or if it's not. And this gave students so much more confidence. We did a quasi-experimental, we did student observations, and the interaction we saw, the change, the confidence, the engagement was fantastic. So I suppose that was kind of my very first knowledge to action type, project. And then secondly, very much biased in this, it was definitely launching my startup and founding my startup. I had worked again in healthcare with 10 years. I've been nursing full time in the CUH, quite close to us all here in Cork. And I just couldn't understand why we were spending so much time on paperwork, and everyone knew it was a problem. And I got a lot of, this is the way we always did it, and that'll never change. And I really couldn't stick it. And I suppose I had to have confidence in myself that this is really an issue and we really can provide a solution. So I think that project was the journey and transitioning from, I suppose an idea, clinical problem from bedside to Briorette or from Briorette, to bedside and business plan and all that. And it was, I suppose, going through the journey, the Ignite program in UCC also, I did that for the year last year. And just the whole project of that in itself, we went from the idea to developing software with Google London, launching it into nursing homes here in Cork. It's just been fantastic and it's still going. So yeah, I think they're definitely two of my favorite projects to date.
Thank you for that. And I think hearing that you started a business is so interesting, because it's a different perspective on STEM and what you can do with STEM, that you can take a clinical problem and move that into a business field. I just think it's fantastic and it's such an interesting perspective. So we'll finish with Shellie. What are your most interesting projects?
I would have to say the first one that I got really excited. I mean, my PhD was really exciting, but I drove that. But the thing that kind of was like, wow, I did not expect that, which is really I kind of think what makes science really fun, was my first postdoc. And I was hired to try to understand why these tiny nanoparticles were wrecking the process of taking old nuclear fuel and vitrifying it, which meant just making it into glass, right? But I had to understand that in a liquid cell inside a TEM and do all of this live and try to understand that. However, I couldn't use the pH in the microscope, and so I started just looking at it in water. And then I actually noticed, well, actually, instead of just using the microscope to image this and analyze this, why not use the electron beam itself to probe the hydrogen network inside there? So I kind of went from a completely different approach, but I ended up going, okay, actually I can use the electron beam to probe the chemistry within the different particles. And so then from that we were kind of going, well, actually maybe we don't use like some caustic, toxic chemicals to dissolve these little nanoparticles. Why don't we use UV radiation? Because at the end of the day, that's really what it was. And then, so that was quite exciting. And so that's really when it sparked that real big interest in going, I really want to use the electron beam for other things, which is then what got me to the fellowship that I'm starting my group with, where why not use the electron beam as the applied electric field for electronic device kind of materials. So in this case, the big question for these like quantum materials, they're all based on what is called like a domain wall. What's happening? So these like lines of conduction, so like a nanowire, are moving back and forth. Well, how are they moving, and why is one insulating and why is conducting? And then I was able to use the electron beam probe to actually move those domain walls. So I actually got to watch the atomic columns move up and down. And so when it's up, it's like charged in a certain way, and that means you get a conducting line of channel, and then if it goes down, you get insulating. So that's really cool just to watch. So I kind of call it like a domain wall dance, which everyone mocks me over, but it's true. So you literally, I get like, my job is watching atoms move around, and I get to control that. So yeah, that's really what I am absolutely excited to keep going with that now for the next 5 years over in London.
Brilliant. It's so nice to hear the passion in your voice when you talk about what you do. I think that's all any of us could want out of our job, to be honest, is to be passionate about it. Also, sorry about my lights switching off. I'm in a room on campus, and obviously we're all energy friendly in UCC, but clearly the lights had enough. So if that happens again, I do apologize. I'll just have to go and turn them back on. But moving on from that, we clearly have a very varied panel in a wide range of fields, and I think that's really important when we're talking about women in STEM. So I'm just going to ask you, where do you see the future impact of women in working in STEM, both in your fields and maybe overall if you're in a more interdisciplinary role? So we might start with Sarah for that.
Sure, and Julia, I think I suppose in terms of my own discipline, I think the big issue is that it has very much become a multidisciplinary based problem now, and a problem that needs to be addressed by numerous disciplines. Because while I was mentioning a little while ago, I started off really working on diseases in marine organisms. Now it's very much encompassing the whole environmental impact, climate change aspects, you know, all the various external factors that drive disease in aquatic organisms, and actually how disease moves in marine systems. So even, I suppose, a lot of the work I would do is how are fisheries and aquaculture going to be impacted over the next 50 or 100 years in terms of animal health due to things like environmental degradation, due to climate change. And again, I think for me, it's really, we're very much going towards a multidisciplinary based focus in terms of how we solve these problems, because no one discipline has all the answers. So for me, it's really the interface of how all the disciplines work together now and work across the disciplines. That's the really exciting aspect of my work anyway.
Yeah, and I think this is just something we keep coming back to about the value of multidisciplinary teams, because there's obviously this whole thing that diverse teams yield better results. And so the benefit of women in STEM goes beyond even moral benefits. There's business benefits there as well. And obviously, especially as a mathematician, I think the whole foundation of being a mathematician is being multidisciplinary, because you can kind of slot yourself into a lot of different fields of research. So thank you. I think it's really interesting. We might go to Kelly next.
Yeah, I mean, I would just agree with Sarah. I'm working in a field that is extremely multidisciplinary, even though I'm a biochemist, molecular biologist by training. I actually really appreciate Ali Rose's contribution about the Ignite program, because I'm entertaining this idea of doing a startup, and it would be a diagnostic based off of the research that we're doing. And I never would have thought that this would even be remotely possible for me. I never imagined it, and I will need, of course, a lot of help. So I think there are just huge opportunities for all people in STEM subjects, because we really do need well-trained scientists, mathematicians, physicists. We need all of that. And in cancer biology, I mean, a lot of the kind of the imaging and the diagnostics that are happened are very much physics based. They're understanding light, they're understanding probes, they're understanding, microscopy and levels that that has really come by understanding physics. So, and math and just the fundamentals that has to be there before you do all the cool things like Shelley's doing with her microscopes and but are really telescopes, as she told us. So yeah, the fundamentals have to be there, but I think there's just massive opportunities and really working in teams, and that is so important, and is really just bringing a team along to solve a problem. So thanks.
Yeah, thank you. And thank you for flagging the Ignite program. Again, I think it's just so nice to hear about the opportunities that are on campus for UCC students, and particularly for women in STEM going into the future, so that you're supported if you do have an idea that you want, maybe do you want to pursue further. So I mean, speaking of that, we may as well ask Ali Rose next what she thinks with the future of women in STEM, maybe even from a business perspective.
Yeah, of course. So I never would have imagined myself in business initially. My family had always been involved with business, and I was, nope, I'm going nursing, that's it, Shinny. So it's funny because as nurses in general, and I'm just speaking personally, we don't see ourselves as innovators, when in actual fact, we are very innovative. If you have 3 ventilators, you have 16 patients, you have 3 ambulances waiting to come in, you have 5 multidisciplinary teams looking for you, and you can't find the phone, you're very innovative. So in fact, we actually need to give ourselves more credit as clinicians, be it occupational therapists, speech and language. We are, highly skilled, healthcare workers, but in actual fact, we have lots of transferable skills that are highly valuable in other areas of research. And I think that's what makes, I suppose, our product, SafeCare, which is our company, just so valuable, because we leave the nurses create the product. I'm not coming at this saying, bet you never knew you couldn't live without this. I'm saying, what is your problem? How much time are you spending on this? Why is it an issue for you? And I think I would be quite altruistic in that I'm still nursing, and it is about giving time back to those that need us the very, very most, those in the care homes. But in actual fact, if you have the right resources around you, i.e. Ignite, perhaps, to put in the business plan, what's your return on investment, get someone to help you with the accounts, it's so astonishing to see where you can go. And it's about empowering women. Again, I never would have saw myself fallen into, a founder CEO role, not in a million years, but yet here we are developing software in London, in Ireland, with a, much larger team. And it's just fantastic. So again, it's, in UCC, we provide these resources to empower, especially young women, to get out there and actually be female founders, create, explore, sell products, and just, be whatever you want to be with your science.
Yeah, and I especially think with all the public discourse there's been in the past few days about nurses, it is amazing to have someone come to the panel and speak so highly of nurses in your transferable things. I think it's very needed, and it's so nice to hear. It's a discussion that probably isn't hand up by how nursing fits into the STEM field as well. So thank you for that. And we might, just before we move on to the final 2 panelists, we will be taking questions at the end. So if anyone has any questions for our panelists, please do start shooting them into the chat box so I can start working away with them when we're done on our last 2 questions. But next we might move to Shellie. Where do you see the future impact of women working in STEM?
Oh my gosh, there's so much. I mean, the great thing about doing the PhD, like even in UCC, was that we did this, and we did a higher diploma in business as well. And again, I was like, oh, never, absolutely never. Like, I didn't think of myself in that way. And then even going like, why did I choose chemistry? Probably at the time. And then why did I move into nanoelectronics? Was because when I was doing Leaving Cert, I didn't think that I could do that, And then what I realized is I keep slowly moving into this male dominated area, which I think is obviously changing and becoming more, luckily, equal. But yeah, even thinking about why not, we're half and half, so why not have the other half of the population as well? You're just losing out on all those bright minds, and I think things are really, really changing, which is great. not only is it diversity like in gender, it's also backgrounds. Because I think what's great about even working in a research group, like I loved doing my PhD in such a diverse group from all around the world. Because even that, you might not think that that's important, but I remember even discussions in a meeting going, oh, actually, I never thought about trying that. And that was just literally something that they had talked about in their secondary year or high school or something like that. But like the multidisciplinary, I've changed from so many different groups and so many different backgrounds, like, why am I in a physics department? Because apparently what I'm doing at my university is physics, and then I go somewhere else and it's chemistry department or engineering. But it makes it really, really exciting every single day. And even during lockdown, I finally got around to doing coding, because I can take all these data sets and I can say, okay, the atom moves in this way. But if I can't quantify that data, there's literally no point to taking the images. And so even within our group, a lot of, the people that we weren't so comfortable with Python and everything like that, that was one benefit, for this lockdown, was like, what kind of forced us to do non-experimental. And even with that now, one of the people in their group has published a whole software just during that lockdown to where we can quantify these little tiny shifts of atoms. So yeah, working with loads of different people is great.
Yeah, and I think that's really, again, when we look at the future of women in STEM, like it can be intimidating, especially, I'm just speaking from my own personal experience as a math student, to walk into a room and realize you're the only girl in there. Like, it's just jarring, and there's something about it that is. But I think it's so important to highlight that, like, the future of women in STEM is really that's going away, and that's not something that you should ever see as a barrier to stopping you doing what you want to do. And you should also consider that if you don't know what you want to do right now, like you said, you can fall into a completely different field. So just go for it, guns blazing. Exactly. And I think it's appropriate to finish with Denise, because I think especially with physics, there's probably a lack of girls, as some would say. So I'd love to hear your perspective.
Yeah, there's definitely a lack of women in physics still. I think I'm going to say something kind of similar, but a little bit different to some of the things that have been said so far. I really hope that as more women get into STEM, it will actually help change the culture for doing scientific research, so that it becomes more based on cooperation rather than competition. Because there can be times when the scientific culture and pressure to publish and lots of things can feel a little bit testosterone charged. I feel like maybe we could do well if we had less ego and more working together for a common goal. And there's no need to be pushing ourselves forward and saying, I'm great, my group is great, we're the best. If you're doing good work, you'll be respected. I also feel that there's more room for results that maybe initially will not be strongly statistically significant. They might be somewhat speculative, or maybe qualitative in nature, maybe based on intuition rather than firm statistics. But such results, although they can lead to very interesting things, are often extremely looked down on. And I've even seen them like openly mocked in scientific conferences, which I don't feel is appropriate at all. I feel that scientific research in general could benefit from allowing a bit more room for intuition, which I think of as more of a feminine trait, as a way to identify research directions that then you do want to sort of follow up and do much more quantitative studies of. So I'm hoping that actually getting a better balance of women in STEM will help the scientific research culture evolve in a positive way.
Thank you. I think that's actually a really interesting point that we haven't touched on, is bringing feminine traits into research. Because I think, I'm sure Denise knows about this, if you look at the collaborative efforts of women here in UCC, we have a group called EPONA, which is Equal Physics Opportunities Network in Academia. I could be incorrect about that, but even just the fact that that was founded and that's there shows how women can come together and work really well in collaborative groups. And I think that is always going to be missing in academia until there's an equal gender balance, and it is a shame, and it probably does lead to oversight on some results perhaps. So there isn't any questions yet, but I will give it a few minutes if anyone does have any questions for our panelists, very experienced panel, so I think they'd be well suited to answer any questions anyone may have. Just shoot them into the chat box. I suppose just while we're waiting to see if there's any questions to come in, do any of the panelists have anything they'd like to add to the discussion on women in STEM? I suppose in particular women in STEM and UCC. Obviously, so the Women in STEM Society was founded 2 years ago, and we've been very fortunate to have a lot of success so far. So someone's actually raised their hand. I presume if you've raised your hand, you have a question. You can just unmute yourself if you'd like to ask the question out loud. Okay, there's loads of questions after coming in at once. Could John Jared McInerney, do you?
Yeah, I do.
I'm
sorry. I'm trying to work the controls here. I'm not used to Zoom.
You're okay.
I've long tried to be gender blind when it comes to dealing with science and with just the culture and the sociology of science, as well as the practice of it. When I was a PhD student, we had 5 students in the group, and 2 of them were female. They were outstanding, and nobody thought of them as girls. We thought of them as colleagues. But there are 2 quite hard filters that I've found in physics. There's one at the entry point where we don't seem to be attracting enough girls to start studying physics. We struggle to get above 15%. The ones we do attract are extremely good, and we're lucky to have them, but we want more. I mean, as you said, there's no future in losing the talents of half the population. I mean, it's just not a good strategy, but we struggle to get above 15%. I think in UCC we occasionally do better, but not consistently. We have had some excellent PhD students who are women, but then another hard filter comes at the point where a postdoc is going for a real job, as we would put it, be it a staff scientist position or a faculty position or something like this. And these, as you know, involve some very intense work and publications and often frequent moves and things that are very disruptive to family life. And I think we overdo it, and I think we turn a lot of people off, and we make it very difficult for women of the age, which would be, sort of early to mid 30s, to compete. And I don't know how to deal with that either. But we have to, because that is where we lose a lot of our talent. Now, the observation about things becoming multidisciplinary, that is really important, because physics, as you know, has given a lot of techniques and a lot of methods, a lot of insights into many other sciences. But we've always had trouble dealing with complexity, whereas biologists, this is bread and butter. Biologists are becoming more mathematical, and we're becoming better at dealing with complexity. So suddenly we have important things to say to each other, which even 10 years ago is not the case. We were speaking different languages and, sort of just passing each other by, not because we didn't want to engage, but because we had no common basis. But now we do. And so in our department, we've been looking at biological and medical physics. And I don't just mean, giving people microscopes. I mean insights into the thermodynamics of organs, or the mechanics of protein folding, or using a strand of DNA as a transmission line and seeing how the energy propagates down and how it branches out and where it gets absorbed and where it gets radiated and all the rest of it. I mean, these are fascinating problems, both from the physics and from the biological point of view. Physics and chemistry have always been very close, but we've had trouble making the jump into biology and into medicine because of the additional level of complexity. But I think that jump is now being made, and we need to embrace that future, but we need to do so with engaging the talents of everybody we can find. And I really need advice as to how we can do better. And a lot of it has to do with the mathematics. The level of mathematics taught in girls' schools, for example, has often been a difficulty, because if you don't have honors maths coming in to study physics, it really is a handicap. Anyway, I'll stop talking.
Yeah, I mean, thank you for that. I think that's actually a very interesting observations across the board. It's always interesting to hear from people who are kind of at the front line, I suppose, in subjects like physics. So it's definitely a complicated issue, and there isn't one cut and dry solution to it, to attracting girls. And it's something we focus on in YSTEM a lot, obviously, is how do we attract girls. I really do think, just from a YSTEM perspective, it starts from primary schools, and I do think that's where a big issue comes in. But I suppose it'd be interesting to hear from Denise if you have any opinions on girls in physics, and why there isn't as many of them as there probably should be, given how talented girls are at physics when they do it.
Yeah,
well, there is an issue. there is an issue where physics has been, unfortunately, very much associated with weapons and war and, you know, things that are really rather regrettable. But you know, when there are wars, people invent things like radar and missiles and bombs and airplanes, and those are basically applied physics. And so we suffer from that association. And don't get me started on nuclear weapons. I mean, you know, if I had a time machine, one of the first things I'd do is go back and make sure we never invented the damn things. But we did, and you know, this is a stain on the honor of physics, and it turns people off. And I won't go any further. You know what I'm talking about. Denise, did you want to come in?
What was your view on that, Denise?
Yeah, I think one of the unfortunate things is that it's not a comfortable feeling to be a minority in any kind of field. I mean, I didn't really think about it much until I got to university. And then I went to a very small university, and there were actually, I mean, comparatively speaking, there was a good fraction of women physics majors. We were 3 out of 15. But even so, you felt that you were a minority. I felt pressure that, you know, if I didn't do at least reasonably well, it might reflect badly on, you know, all of women interested in doing science. So it's got to just be built up to get away from this feeling that, you know, somebody's in a minority and, you know, they need to do well, or else it's going to look like girls can't do physics or chemistry or whatever it is. So I think it's probably got to be built up from the ground up.
Yeah, and I completely agree, especially as a girl in maths. Obviously, like, it is just hard being in a minority, and we can do as much as we can, but it is just a deterrent, and that is something that we try and work on a lot in terms of creating communities like YSTEM on campus to ensure that girls in STEM, okay, maybe we're not in your course, but there is a community there. So following on, we have loads of questions, so I might not get around to all of them, so I'm really sorry if I don't, but Bev Hartline asked, what should male colleagues be doing to help advance and increase women in STEM? In my experience, women cannot drive the transformation because too few are in the power structure, and often they are ignored, or worse, when they advocate for improvements. So I think, Sarah, you might have an interesting perspective on that, just because you are obviously head of the school, so you manage all of us really. So I'd be interested to see what your perspective on that would be.
Sure, thanks, Julia. I suppose in all fairness, the first thing is just that everyone wants to be just treated as a colleague and an equal. And I mean, and not necessarily treated as the female members of staff or the female students or whatever. It's just a group of colleagues working together to, you know, to generate great knowledge, to teach, to learn. So I suppose this is part of, I think, a wider societal issue, you know, and I mean, it's going back to what you were saying a minute ago. It's really about us going back into the primary schools, but it's also really a wider societal issue about how we still divide up chores and how you know, the perception of who's going to go into what career. And I mean, probably we're not fully as progressive as we might be in that sense, you know. So I think from a perspective of people working together, I think the main thing is to be supportive of all colleagues, you know, and that you're working coherently together, and that you really recognize all the individual talents that people bring to a team, you know, whether they're male or female, and that everyone is supported collectively. And I think that's actually the best way. And I've actually been lucky enough to work in teams where we did have a great balance. And I mean, the whole joy of that actually was what individuals brought to the team, the different types of expertise, the different you know, knowledge, and the different life experiences they brought into that group that really helped to make those things a success. So if I was just saying anything, I would be really just be supportive of everyone generally. And I suppose then in the longer term, it's really about how we think about everything we do, even outside of academia, that might be prohibiting people from thinking about STEM careers. And that is, you know, that can start from really unconscious bias, you know, in how little girls are treated, or, you know, comments parents say, or, you know, science is really hard, or it's only boys going to engineering, or the boys gets, you know, different types of choice. So it's a lot of different things, I would say, to be honest.
Yeah, and I think that's a very accurate perspective. What I always say when I do YSTEM talks is both my parents are engineers. So to me, like, because my mom was an engineer as well, it seemed obvious almost that I would be an engineer. Like, there was no relation to gender in my head, and so it didn't really click with me for ages that there wasn't that many girls in engineering, because it just seemed obvious to me. And that's why I think, going back to the societal structure, and say even TV shows, which, like, you have like the dad, like Peppa Pig's dad goes to work and mom stays at home. You know, there's like these small things that I don't think we even realize are there. That is, in terms of that, because things stick in children's minds, I think, more than we appreciate a lot of the time. And it's so important that we really go down to the baseline. And it definitely, in terms of workplaces, I completely agree with the fact that women can't drive that, because how you're treated by your male colleagues is up to your male colleagues. You need to be treated equally, because, like we said, you are bringing something to the team as well. You are bringing a unique perspective, and you need to believe that within yourself, but you also, that needs to be reflected in how you're treated, I think. So we have a question specifically for Ali Rose next. Is there a general resistance in Irish healthcare towards utilising modern technologies or experimenting with new disruptive methods? And that's from Karen McCarthy. It's a fantastic question, I think.
Karen is our fantastic marketing executive at SafeCare. So we'll be having a talk later about the about the challenging question. No, absolutely. Fantastic question, Karen. Yes, there are many challenges in implementing new technologies into healthcare. There's been challenges all along the trajectory, more so in the public sector than the private sector. And there are many different reasons for that. But to wrap it up quickly, because of COVID, we now see firsthand the value that using these technologies brings to the people that need it most: our patients, our children in pediatric units, our grandparents, our aunts, uncles, brothers, sisters in nursing homes. We now have had patients that cannot say goodbye. It is the nurse that is managing 3 or 5 patients that are often in their last final moments of life, within days, within hours. And we are the ones trying to Zoom loved ones to say goodbye. Now, that is the harsh reality of what we're dealing with on the floor. I would love to say otherwise, but what we can do is that we can change the situation we're in, but we can improve it bit by bit. And if that's a Zoom call, if that's, if it's all about me, electronic book, playing someone's, favorite music. There was a beautiful piece on, I think it was LinkedIn or one of those, platforms, showing an absolutely fantastic prima ballerina listening to Swan Lake, and she had all the movements, So again, not the most supersonic AI-induced form of technology, but nonetheless, using music to help people engage in these type care settings. So I suppose to give you the short answer, there are many challenges, but the benefits far outweigh them. And I think it's about the women in STEM. And again, it's funny, we talk about, the gender bias. Well, actually, the poor gentlemen that are nursing too have the same situation. So it's about us on a personal level, being mindful of everyone and, just working, as Sarah said, as colleagues. But yeah, I think it's about us in turn, like on a local level, saying, actually, I see the problem, I can provide a solution, and I'm going to be part of that change. I may not make it happen on my own, but I'm going to be part of it. So yeah, step by step.
Thank you. And I think, especially given the times we find ourselves in, hearing about the place of STEM in healthcare is just particularly interesting. I think we're all on Zoom for a reason, obviously. So for the last question I'm going to ask is there anything you wish you knew when you were an undergrad heading into a career in STEM? And I'm just going to open that to everyone, because I think most of our panelists would probably have an opinion on that. Denise has raised her hand, so she could speak first.
Yeah, this may sound a little bit odd, but it seemed to me when I was a student and then a PhD student and maybe even a postdoc that, I had doubts as to whether I was doing as well as I could do, and some anxieties about whether I was on the right career path and so forth. And it seemed like none of the guys were worried about any of this stuff. And I really strongly suspect that they probably are, they just don't show it. So what I would be inclined to say is that if you feel a bit worried about your career path, or whether you're carrying out things as effectively as you should, and whether you're really capable as you should be, and it seems like nobody else is worried, don't worry, they probably are, and are just not showing it.
Absolutely.
Brilliant. Oh yeah, brilliant. Kelly?
I would just agree with that, because I remember during my PhD, I marched into my supervisor and I was like, well, I'm done. I'm not smart enough. I'm quitting. That's it. Nothing is going well. And it wasn't until, everybody has this happen to them. And, I just thought I wasn't cut out for it. And, I don't know what I would have done. I suppose I always tell people, ask like, what would you do otherwise? And I said I would probably have a cafe where there's really nice coffee, because I don't know what else I do. But yeah, I suppose when I was an undergrad, I guess I sort of had this idea of like how my career would go. And it was not my intention to end up in Ireland. That was never part of the plan. And it was just being open to opportunities that came my way. And I could have never expected to do a postdoc in Germany. I never thought that was possible. I didn't know anything about that. So it's really just being open to what comes your way. And to not get too hung up in that, that you have to be at a certain place at a certain time doing, by X number of years, I need to have accomplished, certain things, because it might not happen that way. So.
Yeah, very true. And I love hearing this. Obviously, I'm still an undergrad myself. So do any of our panelists want to throw in anything to that discussion before we wrap up?
Yeah, I might add something there. I
Yeah,
definitely, if I could go back and tell myself, and I definitely felt, that kind of imposter syndrome, scenarios the Kelly and Denise have spoken about. But I think if I could go back, I would say, Ali, like where you are, like the undergraduate career that you choose, nursing, we'll say, for example, you don't have to do that forever unless that's what you want to do, and I think if I had just known that, I thought, I fill out the CEO, I trot off to UCC, that's it, I can't, like, I've chosen, but I would just love to tell myself that actually you can still do anything you want to do at any time you want to do it.
Yeah, and I think that's always really nice to hear as an undergrad. Shellie, do you want to add something?
Yeah, for me, like what got me through, let's say, even throughout the degree or, going on as postdoc, and you're going to those scary conferences, and I'm probably more of a bubbly and possibly not, I don't fit the stereotype of the research field I'm in whatsoever. I feel very much, I'm like, oh, I'm by myself, is to have other, like, whether it's a mentor or other people maybe that you can joke and laugh with and let that go, so that imposter syndrome, you can let that out to someone else, and then you can have those conversations, and they don't have to be in the same place. If anything, COVID's shown us that they can be halfway across the world, and even things like social media, like Twitter, if you filter out all the politics and then you just focus on the science and everything like that. I've had great conversations with people from my same research field that also possibly don't fit that stereotype, and that helped me with the imposter syndrome anyway.
Thank you. I think this has been a very interesting discussion. I'll probably conclude on a thought I have, and I've heard my friends have heard me say this much. So if I didn't have YSTEM, I would have dropped out by now. And I think that's probably just because I know we have some prospective students here. Do join societies. I think especially as a woman in a male-dominated field, the best thing you can do for yourself is create that network. It obviously isn't ideal that you have to go out and create that network, but if you have one, it makes everything, I think, so much easier. So thank you so much to our amazing panelists. I hope everyone's gleaned something from this discussion. Obviously, the discussion on women in STEM is very nuanced, and we were never going to get it all done in an hour, but I hope everyone has learned something and enjoy this panel, and have a lovely rest of your evening.